Welcome to the DIY Honda Garage channel. Welcome to the diagnostic presentation for the Honda Accord models 2017 to 2023, specifically addressing the DTC P2A01, which stands for Secondary HO2S, Sensor 2 Circuit Range Performance Problem. This diagnostic trouble code, DTC, indicates a potential issue with the secondary heated oxygen sensor, HO2S, which plays a critical role in monitoring exhaust gas levels to help manage the vehicle's air-fuel mixture and emission systems. Located downstream of the catalytic converter, the secondary HO2S can provide vital feedback to the powertrain control module, PCM, about the efficiency of the emissions control system. If this sensor detects values outside of its normal operational range, it can significantly affect engine performance and emissions. Understanding the role of this component will help technicians troubleshoot effectively and restore proper function. The error code, P2A01, specifically pertains to the secondary heated oxygen sensor, known as HO2S2, which plays a pivotal role in measuring the levels of unburned oxygen in the exhaust gases coming from the engine's combustion process. This sensor is positioned downstream from the catalytic converter, allowing it to monitor the effectiveness of the catalyst in reducing emissions. By evaluating the oxygen content in the exhaust, the secondary HO2S can help provide necessary data to the PCM, which adjusts fuel delivery and ignition timing to optimize engine performance and emissions. If the readings from the secondary HO2S are outside expected performance ranges, the PCM will trigger the P2A01 code, indicating a need for further investigation into the sensor or its associated wiring and connections. Troubleshooting the P2A01 DTC requires understanding several potential causes. A faulty secondary heated oxygen sensor is a primary suspect. Over time, this component can degrade or malfunction, yielding inaccurate readings. Another possibility involves wiring issues, which can arise from wear, corrosion, or physical damage to the wires leading to the sensor. Poor connections, whether at the sensor itself or within the connectors leading to the PCM, can also result in intermittent signals. Each of these causes could lead to erroneous signals being interpreted as a malfunction within the oxygen sensor circuit. Properly identifying the root cause is essential to effectively resolving the P2A01 error. When the P2A01 code is present, several symptoms may manifest, reflecting the issues associated with the secondary HO2S. Drivers may experience poor engine performance, including a rough idle, hesitance during acceleration, or even stalling, particularly under load conditions. Increased emissions are another common symptom, as a malfunctioning secondary HO2S may not accurately report the exhaust's condition, leading to improper fuel management and higher pollutants. Additionally, the vehicle may trigger a check engine light, alerting the driver to the presence of an issue. Recognizing these symptoms is crucial for both diagnosis and troubleshooting to ensure compliance with emissions regulations and optimal vehicle performance. The first step in the troubleshooting process for the P2A01 code is problem verification. Start by turning the vehicle to the on mode. This allows the engine management systems to initialize. Next, clear the DTC using the Honda Diagnostic System HDS. Subsequently, start the engine and allow it to idle for at least 10 seconds. The purpose of this initial step is to determine if the DTC is still present or if it was an intermittent issue. After this, use the HDS again to check for any pending or confirmed DTCs. If P2A01 is indicated, it suggests a consistent failure. If not, further investigation into potential loose connections or wiring issues may be warranted. Step 2 involves checking for a shorted wire in the secondary HO2S circuit. First, turn the vehicle to the off or lock mode. Then, jump the SCS or service check signal line using the HDS. This process allows the diagnostic tool to engage in deeper diagnostic checks. Wait for more than 1 minute following this action. Next, disconnect the PCM connector A, which contains 50 pins. The next critical step is to check continuity between the designated test points using a multimeter. Test point 1 is the male terminal number 1 of the secondary HO2S, and test point 2 connects to the body ground. If continuity is present, it indicates a short in the SO2 wire, and repairs will be necessary. Step 3 is characterized as an open wire check for the SO2 line. Again, ensure that the vehicle is in the off or lock mode, and both the secondary HO2S and PCM connectors are disconnected. Utilize a multimeter to assess continuity between point 1, the secondary HO2S male terminal 1, and point 2, connector A pin number 47 of the PCM. A successful continuity check confirms that the SO2 wire is intact and operational, allowing you to advance to step 4. Conversely, if continuity is not detected, it suggests an open circuit, thus requiring repairs to the wire segment between the secondary HO2S and the PCM connection. In troubleshooting step 4, the focus shifts to checking for shorts in the SO2SG, SO2SG line. Following the established testing conditions, turn the vehicle to the off or lock mode. Ensure the secondary HO2S and PCM connectors remain disconnected. To perform the continuity test, use your multimeter to check between the secondary HO2S terminal number 2 and body ground. If continuity exists, it suggests that there is a short in the SO2SG, SO2SG wire, which connects to pin A48 at the PCM. If continuity is absent, proceed to step 5, as this indicates the absence of a short and suggests further testing is required. The fifth troubleshooting step consists of an open wire check for the SO2SG/SO2SG line. As with previous steps, ensure the vehicle is off and all necessary connectors are disconnected. Connect a multimeter to test continuity between the secondary HO2S male terminal number 2 and the corresponding pin number 48 at the PCM connector A. Achieving continuity in this test reveals that the SO2SG/SO2SG wire is functioning correctly, allowing you to advance to the next step. However, if the multimeter reveals an open circuit, then the repair should focus on addressing the break in this wiring segment between the secondary HO2S and the PCM. In the final troubleshooting step, you will perform a check on the secondary HO2S itself. Begin by substituting the original sensor with a known good secondary HO2S to eliminate the possibility of sensor failure. Once the replacement is in place, reconnect all previously disconnected connectors and exit SCS mode using the HDS diagnostic tool. Next, turn the vehicle to the on position again and clear the DTC with the HDS, allowing the system to reset. After waiting for at least 10 seconds, check for any pending or confirmed DTCs once more. If P2A01 does not reappear, it suggests that the secondary HO2S was indeed faulty. If the code is still present, further investigation into the PCM or related systems may be necessary. After completing the troubleshooting process, it's crucial to verify that all repairs have been successful. Start by running the vehicle to check its performance under normal operating conditions. Pay attention to any symptoms that were previously present before the repairs to confirm they have been resolved. Additionally, utilize the HDS to scan for any error codes. Successful repairs should yield no new DTCs. In instances where DTC P2A01 appears again, it may indicate that other underlying issues are still at play, warranting further examination of the vehicle's emissions systems. Proper verification helps ensure that the vehicle not only runs well, but also meets required emission standards. Preventive maintenance is key to avoiding future occurrences of the P2A01 code and ensuring engine efficiency. Regular inspections of all oxygen sensors, including both primary and secondary versions, can help identify early signs of wear or malfunction. It's particularly important to check the wiring and connections leading to the sensors for any signs of corrosion, fraying, or disconnection. Carefully maintaining the exhaust system also contributes to optimal performance. Any buildup of residues or clogs can add undue stress on the sensors. Implementing routine maintenance checks can significantly minimize the chances of encountering the performance problems associated with the DTC P2A01 down the road. In conclusion, diagnosing the DTC P2A01 involves understanding the critical role of the secondary HO2S and its influence on engine performance and emissions management. By systematically following the diagnostic steps outlined, technicians can accurately trace the source of the problem, whether it be a faulty sensor, wiring issue, or torque connection. Successful repairs not only involve replacing faulty components, but also verifying that the vehicle operates within expected parameters with no lingering DTC codes. Emphasizing the importance of preventive maintenance can further enhance the longevity and reliability of the vehicle's emissions system and overall performance. Keeping these considerations in mind will ensure that Honda Accord owners can enjoy both optimal performance and compliance with emissions regulations. Please like and subscribe to the channel. See you next time.